So now I'm going to work through some examples. And with these, we're told in advance that the integrals do converge, and we just want to evaluate them. So the first one here, we're looking at the integral from 0 to infinity of dx over x squared plus 1. So what I'm going to do is I'm going to take that upper bound of infinity, replace it with b, and then we're going to look at the limit as b approaches infinity. Of the integral from 0 to b, not 0 to 1, 0 to b, of dx over x squared plus 1. Now, if you go to your integrals table, and it's probably handy to have a copy of that out, but if you go to that table and you look at number 17, you'll see that this integrates to inverse tangent of x. So as we're looking at the limit as b approaches infinity of inverse tangent of x, and again, we're going to evaluate that from x is 0 to x is b. Okay. And again, that was number 17 from the table. So, got the limit as b approaches infinity of inverse tangent of b minus inverse tangent of 0. Now, it may be helpful to look at a graph of inverse tangent function, but as b goes to infinity, the upper limit of your y values for that function are going to be pi over 2. So that limit is pi over 2. And then inverse tangent of 0 is just 0. So we have pi over 2 minus 0. So this converges to pi over 2. I'm going to do another one here. This one, both the upper and the lower bounds are going to go off to infinity, one positive, one negative, of course. So I'm going to break this up into two parts. When you break this into two parts, for the first one, you're going to let a be that lower bound, and we'll look at the limit as a goes to negative infinity. And you want to split it at some value. I'm going to just pick 0 because that's just an easy value to pick, but you could pick any number you wanted here. So that takes care of kind of half of it. And then we need to look at the limit. So this, we looked at it from basically negative infinity to 0. So now I'm going to look at it from 0 to positive infinity. So we'll start with the 0 here. I left off at 0. I'm going to start back up with 0. So here we're going to look at the limit as b approaches infinity. Integrate this from 0 to b. Now, the nice thing here, if you want to look at it from this perspective, is that we are integrating the same function. So we're going to be going through a lot of the same steps here. I'm going to do a u substitution to integrate this. I'm going to let u equal x squared plus 1. So you can see it's the same thing in both. And if u is x squared plus 1, then du conveniently is equal to 2x dx. Okay, so you can really see what's going to happen there on the inside of these integrals. I do need to change that value of 0, though, to now match the u substitution. Since a and b are going to negative infinity and positive infinity respectively, that's not going to change. You know, squaring infinity is still infinity, right? It's an idea, not an actual number. So I really only need to worry about the 0 here. If x is 0, 0 squared plus 1, this is now going to change to a 1 because I'm doing that u substitution. So writing it out, this is what I I've got the limit as a goes to negative infinity of the integral from a to 1, and it's going to be du over u squared. Over here, it's the limit as b approaches infinity. We're integrating from now 1 to b, and again, du over u squared. So in both cases, when I integrate, I'm going to get negative 1 over u. So I've got the limit as a approaches negative infinity of negative 1 over u. We're going to evaluate that from a to 1. And then over here, doing something very similar. So now when I substitute in, I'm going to get negative 1. Negative 1 over 1 is negative 1. Then it's minus the negative, so it'll be plus 1 over a. And then here we've got the limit as b approaches infinity of negative 1 over b minus a negative, so it'll be a plus 1 over 1. Now, as a goes to negative infinity, 1 over a goes to 0. So this first limit, I'm just going to be left with that negative 1. For the second limit, as b goes to infinity, negative 1 over b also goes to 0. So over here, I'm left with a positive 1. So when all is said and done, this converges, and it converges to 0.